Hello viewers, welcome back to this course. So, today we are going to start with the lecture number 6. So, in the previous lecture we have started dealing with second order non-homogeneous linear differential equation with constant coefficients, and in that case we have discussed that how we can solve. So, this system we have solved with, first we have solved with the homogeneous part, and that is written as a y double dash plus b y dash plus c y equal to 0, and from here we have solved this equation with the help of characteristic equation, and then we found the complementary solution that can be written as c1 y1 x plus c2 y2 x. So, in this case y1 x and y2 x, they are the linearly independent solution of this equation. So, once we know the solution of the corresponding homogeneous equation, then we have started with solving non-homogeneous part. So, this is the homogeneous part, and in that case we are going to find out the particular solution, and that we have represented by ypx. Now, we have found the ypx for cases when fx was some exponential function ax, and also in the previous one we have started with a trigonometric function which has sin alpha x, or this is also alpha you just take because a we are taking as a coefficient of y double dash. So, sin alpha x or cos alpha x. So, in that case we have already solved that how we can solve this type of differential equation. Now, for the sin for fx is equal to sin alpha x cos alpha x, in the last class we have discussed that we get f d square sin alpha x, and we put instead of d square we put f of minus alpha square sin alpha x, and then we solved. So, in the last class we have solved one example also. Now, I am taking the case. So, this is the case I am taking. What about when f of minus alpha square becomes 0? So, this is the same case as we have also done for the exponential case, when e raised to power alpha x and alpha is the root of the corresponding characteristic equation. So, then how we can solve this one? So, in this case, so let us do one example. So, this can be done with the example. So, let us take one example. So, example I am going to solve that, suppose we have y double dash plus y is equal to 6 and sin x. So, in this case I know that my my complementary solution ycx will be, because the homogeneous part will be y double dash plus y equal to 0. From here I will get the characteristic equation d square, I will get the characteristic equation lambda square plus 1 equal to 0, and from here I will get the lambda is equal to plus minus iota. So, in that case I will get the solution. So, my complementary solution will be c1 sin x plus c2 cos x. Now, so this is my complementary solution, and you can see from here that sin x is appearing in the solution, and sin x is also the function on the right hand side. So, in this case now I want to find the particular solution. So, how will find out the particular solution? So, that we are going to discuss. So, my particular solution ypx in this case will be 1 over d square plus 1 6 sin x, because sometime also we can write this one as, generally we write this as minus 1 6 sin x, but in the some books just to solve this one, this inverse we also represent by this way. So, this one I want to solve. Now, if I put and apply the same formula what we have done here, in this case if I put minus 1 instead of d square, then this becomes 0. So, this is the case when f of minus 1 becomes 0, because my f of d square is d square plus 1. So, when I put this in the instead of d square I put minus 1, then it becomes 0. So, this is the case from here. Now, so after doing this one, so how to solve this type of equation? So, there is always some tricks to solve this type of equation. So, in this equation what I will do is that I will take d square plus 1 inverse 6 I can write here and sin x. So, this I generally what we do is that I will write this as the same, and the sin x I will take EIX, because EIX I know that EIX is cos x plus I sin x, and I want to solve for the sin x. So, I will put imaginary part of EIX, and this further can be reduced to 6 d square plus 1 inverse, and from here I can take this imaginary part here. So, I can write 6 and the imaginary part of this EIX, this one I can do. Now, so after doing this one, from here what I will get is that my ypx becomes 6, and now I apply the formula taking multiply by 1. What we have done, that taking the product of two function and then operating it with some operator. So, what we do is that in this case I will apply the previous formula, and then I will take EIX on the left hand side, and my operator will become d plus I whole square plus 1 into 1. So, in this case this can be written as EIX, and imaginary part is also there. So, you always do not forget to write imaginary part. So, I will write here 6 and then imaginary part, and in this case also I will write imaginary part of 6 EIX, and this one I can expand. So, it becomes d square plus I square plus 2 di, so that plus 1 and operating on 1. So, this is my operator. So, this becomes 6 EIX, and this d square will be there. This I square is minus 1, so this will cancel out with this. So, you will get 2 di operating on 1. Now, so this is my operator, which can further be reduced to imaginary part of 6 EIX, and now this is the 1. So, from here I can take this function as d square 1 plus 2I d1, this one can be written like this. So, I will write in this case imaginary part 6 EIX, and d square of 1 is, if I taking the one time integration, it will be x. So, another time it will be x square by 2 plus 2I into x. So, this will become. So, after doing this one, I just want to take the imaginary part of 6 e I x, and this become. So, further I can reduce this one. So, this equation can be further reduced. Now, it becomes 6, and this is cos x plus I sin x, and multiply by x square by 2 plus 2 x I. So, this one I want to do. Now, I want to find the imaginary part. So, now multiply. So, if I take multiply 6 cos x multiply by x square by 2, then this is the real part. But if I take 6 cos x into 2x, then it will be a imaginary part. So, it becomes 6 cos x into 2x, and then from here I sin x will multiply by this one. So, it will be 6 sin x x square by 2, and other part here will be I into I, that will be become the real part of that one. So, from here so, from here I will, what I will get is, now then sin x is x square by 2 plus 6 cos 2x. So, that is my particular solution. So, this is my particular solution, and then from here I can write my general solution yx. So, this will be ycx plus ypx. So, this can be. Now, the thing is that, okay, no, there is one mistake I have done. It was the inverse also here. So, we have to go back and just erase this one, because it is the inverse function. So, we have to do the inverse here. So, let us do again. So, this will be imaginary part of, and from here I can take my d inverse common. So, inside I will get d plus 2y, and that is the inverse of 1, and 1 I can put as a 0x. So, from here I will get imaginary part of 6 e I x and d inverse, and this one I can solve just what we have solved for the exponential function. So, I put, instead of d I put the 0 here. So, I will get 0 plus 2i inverse into e 0x, because 1 can be written like this one. So, from here I will get imaginary part of 6 e I x and d inverse, and this will becomes 1 over 2i into 1. So, if you solve it further, you will get 3x cos x. So, that will be the your solution. So, in that case my general solution will be C1 cos x plus C2 sin x minus 3x cos x. So, that will be a general solution for this particular problem. Now, this is the case we have solved for the equation when the right hand side function is a sine function. Now, we go further and take the next case. So, this is case number 3, when my right hand side function f x in the equation is x raised to power some alpha, where the alpha is positive and integer. So, like on the right hand side I may have x square, I may have x raised to power 10, I may have x power 10 plus 2x square plus 1, like this one. So, when the a polynomial of this type on the right hand side, then how we can solve this one. So, in that case my particular solution will be f d inverse x raised to power alpha. Now, x raised to power alpha is that, and this is the integral operator. So, how we can solve this type of solution when we have ypx? So, let us do one example, and based on that example we can check or we can show that how this type of function on the right hand side can be solved. So, let us solve this example. So, let us take y double dash plus 16y is equal to 64 x square. So, 16 for x square. So, in this case my ycx will be c1 cos 4x plus c2 sin 4x, because I know that my characteristic equation will be lambda square plus 16 equal to 0, and from here I get the lambda is equal to plus minus 4i, and then I can find the solution based on that one. Then, so from here now I want to find the particular solution. So, how we can find the particular solution? So, in the particular solution I will get my f d inverse into 64 x square. So, that is my solution on the right hand side. This can be written as, I can take 64 here, and my f d in this case will be d square plus 16 inverse x square. So, this again can be written as, so in this was 64, and I can take from here the 16 I can take common. So, if I take the 16 common with the inverse, so it will becomes 16 here, and inside I can write d square over 16 inverse x square. Now, this further can be reduced, and this can become 64 by 16 1 plus d by 4 square inverse x square. Now, what we do is that this one I can solve with the help of the binomial expansion. Like I know that the binomial expansion of 1 plus x raised to power minus n, or minus n or plus n, I can just do with the any value of n. So, this can be written as 1 plus n x plus n minus 1 by 2 factorial x square plus n minus 1 n minus 2 by 3 factorial x cube and so on. So, what you do is that we expand this inverse with the help of this binomial expansion. So, once so after doing this one, so from here my ypx can be written as, so it will be 4, so this will be 4, and then this I expand, so I will expand it by the formula. So, it will be d square by 16 from here. Then I can write this one as, so in this case my n is minus 1. So, 1 plus x minus 1. So, what you will get from here? You will get 1 minus x, because in the instead of n I put the minus 1, and this will be minus 1 and minus 2, this will cancel out. So, this will become x square, again this become x cube and so on. So, from here I can apply this formula. So, this will become d square over 16 square by this formula and so on, operating on x square. Now, this will keep going with, because this is an infinite series, but I know that x square is the function, and if I take the first derivative it will be 2x, second derivative it will be 2, and after that become 0. So, in this case this infinite series will truncate till d square. After that there is no need to take the terms of belonging to d square more than the power of d square. So, it becomes plus. So, I can operate this on the x square. So, it becomes x square minus 1 by 16 d square x square, and that is it. So, after the, because it becomes the power of 4, so that operating on x square it becomes 0. So, from here I will get 4x square minus, and this will be 1 by 4 and it will be 2. So, this will be 4x square minus half. So, once I get 4x square minus half, so from here I can solve my equation yx is equal to c1 cos 4x plus c2 sin 4x, and then this solution y 4x square minus half. So, that is the solution of the equation when the right hand side function is 64x square. So, this type of terminology we can use whenever we have a function on the right hand side, and that is the polynomial. These same things we can apply. The question comes that why cannot we apply the same thing for the other function like the exponential function or the sine function, because in this case we know that we have an infinite series, and I suppose I take the function f x on the other side, on the right hand side is alpha x, and I operate this series on this function, but this is exponential function. So, if you keep taking the derivative of this exponential function, it is not going to become 0 when does not matter that you are which order you are taking the derivative of this function. So, this function, the derivative of this function never becomes 0. So, in that case we are unable to stop or truncate this series. So, that becomes a very difficult to find out. So, that is why we cannot apply this method for this type of function, or we cannot apply this type of terminology for the function whenever the trigonometric function is there. So, in that case also this sin alpha function is keep going on whenever we take the derivative, and is not going to become 0. So, that is why these two functions we cannot apply this terminology, but whenever we have a polynomial of this type whose derivative after some time becomes 0, in that case we can apply this formula. So, this one is over. Now, after that, now till now I am able to solve the differential equation whose coefficients are constant, and the right hand side function is either the exponential or sine cos function or some polynomial. But what about if I want to solve a differential equation such that I have some general form a 2x y is equal to some function f x, where my x belongs to some interval, belongs to real line, and my function a naught x, a1 x, a2 x and my f x are continuous on I, and a naught x is never 0, belongs to I. So, in that case I have now a general. So, this is the general second order linear differential or non-homogeneous differential equation. So, this is my functions, and now I do not know that how we can solve this type of equation, but there is a very famous method, that method of variation of parameter. So, this method is used to find particular solution of the equation. So, let us give it a name. So, I give it name equation number 1. So, this method of variation of parameter is used to find the particular solution of general equation 1. So, this is when any two solutions y1x and y2x, y1x and y2x. So, this y1x and y2x are linearly independent. So, this we can find that the particular solution we can find when any two solution y1x and y2x of the homogeneous corresponding homogeneous equation a naught x y double dash plus a1 x y dash plus a2 x y equal to 0 is known to us. So, this is the very strong condition that y1x and y2x which are linearly independent and the solution of this equation is should known to us. Only then if I know this solution I can proceed to find out the particular solution of any differential equation with any fx, because fx is exponential, then I know that how to find out, but this is in this case we are taking the general form. So, a naught x, a1 x and a2 x, this is the function of x. In the earlier cases we are taking the function where this a naught, a1, a2 are the constant function. So, this is the condition. So, this is the method that how we can proceed to find out the particular solution, and this is known to me. Now, let ypx is my solution. So, I should write not here yp, just yx, I just write yx. Let I take yx is a solution of, so I know that if I know the value of y1x, y2x, I can write my complementary solution as c1 y1x plus c2 y2x. So, this is known to me, right. So, from here, so this is given, I just write it is given to me. So, now I will take that let my solution yx I take as c1. So, you just write down 1 here, it is a, in this case it was a constant, arbitrary constant c1 and c2, but let us assume that c1 is a function of x and this is y1x plus c2 is also function of x and this is y2x. So, this is I assuming that my c1x and c2x are the function of x instead of c1 c2 that we have taken here as a constant. So, as the method says, the method of variation of parameter. So, I can call it that c1 and c2 are the parameters and this is varying, the x, it is a function of x. Now, so let I take that this is 2. So, 2 is the solution of, since 2 is a solution of equation 1, then now for just for the simplicity to do the some manipulation or taking the derivative, I will take the derivative, I will write y this equation number 2 as y is equal to c1 y1 plus c2 y2, because we have to take the derivative, first derivative, second derivative. So, that is why I am writing the equation number 2 in this form, but it is understood that y is a function of x, c1 is a function of x, y1 and y2 are the function of x and c2 is also a function of x. So, that is understood. Now, from here I take y dash. So, y dash will be the first derivative and I apply this one. So, it becomes c1 dash y1 plus c1 y1 dash plus c2 dash y2 plus C2 y2 dash. So, from here I will just write here C1 y1 dash plus C2 y2 dash plus C1 dash y1 plus C2 dash y2. So, this factor I just take and make this factor is equal to 0. So, from here I take equation that this is 0. So, I call it third. So, I will remove this one. Okay. So, this become there. So, my y dash become this one and y double dash become C1 dash C1 dash and then y1 dash plus C1 y1 double dash plus C2 dash y2 dash plus C2 y2 double dash. Now, I substitute the value of y, this y, y dash and y double dash in the equation number 2, in the equation number 1. So, equation number 1 becomes a naught x and then I put this one value. So, C1 dash y1 dash plus C1 y1 double dash plus C2 dash y2 dash plus C2 y2 double dash plus A1 A1x and then I will put this one C1 y1 dash plus C2 y2 dash plus A2x and then I will put C1 y1 plus C2 y2 is equal to my f(x). So, I have substituted this one. So, from here I will just simplify this one and I will collect the terms corresponding to C1 and corresponding to C2. So, I just collect the terms corresponding to C1. So, C1 becomes, it becomes A naught x y1 double dash and then C1 can be taken from here. So, it will be A1x and then y1 dash and from here it will be A2x and y1. So, this is the corresponding C1 we have collected. Then now I take the terms corresponding to C2, again the same. So, it will be A naught x y2 double dash plus from here it will be A1x y2 dash plus A2x and y2. So, this become plus the remaining term I will write here. So, remaining terms, this is the term I am getting. So, from here I will get A naught x, from here I will get C1 dash y1 dash plus C2 dash y2 dash. So, this is the terms remaining term I am collecting and then become it is equal to f of x. Now, so once I get this value, now what about this function, this equation, what about this equation? Now, if you see here that y1 x was the solution of the corresponding homogeneous differential equation and y2 was the solution of the corresponding homogeneous equation. It means that my A naught y1 dash plus A1 y1 dash plus A2 y1 is 0, because that is the solution of the homogeneous part. Similarly, my A2 y2 dash plus A1 y2 dash plus A2 y2, that is also equal to 0. So, I will put this part equal to 0 and this part equal to 0. So, from here I can write that I will left with only A naught x and then C1 dash y1 dash plus C2 dash y2 dash is equal to my f(x). Now I have assumed that my a naught x is not equal to 0. So this is we have assumed that is not equal to 0, where x belongs to the bounded interval whatever we have taken. So from here I can write this as c1 dash y1 dash plus c2 dash y2 dash is equal to my f(x) divided by a naught x. So we call this as a new function, that let us call it gx. So I will call it equation number 4. So now I will solve. So from the equation number 3 and 4, the equation third was c1 dash y1 c2 dash y2 equal to 0, and another equation is this one y1 dash plus c2 dash y2 dash is equal to my gx. So this is, if you see that this is system of equation, and from here I can write this system as y1 y2 y1 dash y2 dash. So this is my matrix. Here I will call it c1 dash c2 dash, and right hand side function becomes 0 and gx. Now this is a system of equation. So I can solve this system because I want to find here c1 dash and c2 dash. So from here if I want to find c1 dash and c2 dash, I will take the help of this matrices. And now what about this y1? I know that y1x and y2x, they are linearly independent. So from here I can say that since y1x and y2x are linearly independent, it means that y1 y2 y1 dash y2 dash. So this is, I know that this is Wronskian and this is not equal to 0. So if this Wronskian is not equal to 0, then I can solve this system with the help of Cramer's law. So if I apply the Cramer's law, I can find the solution of this one. So my, in that case c1 dash will be, just substituting the right hand side function vector at the first column. So the solution becomes 0 gx y2 y2 dash divided by the determinant of this matrix, and that determinant I know that will be y1 y2 dash minus y1 dash y2, and this is, I know that this is Wronskian. So from here I can write this one as, so if I take the determinant of this one, so 0 minus, so it will be minus gx y2 divided by the Wronskian, that is a function of x. So from here I will get the c1 dash. Similarly my c2 dash I can find out with the help of Cramer's law. So this will be y1 y2 dash, and this will be 0 gx and divided by the Wronskian as a determinant of the given matrix. So from here I will get this as gx y1 divided by the Wronskian wx. So from here now I am able to find the value of c1 dash becomes minus gx y2 as, so I know that y2 is a function of x, so I can write here as this one, and c2 dash is also, I know that the function of x, so it will be y1x and wx. Now I want to find the value of c1. So from here I want to find the value of c1 because I wanted to find out what will be the c1x and c2x. So I want to find the value of c1, so I will integrate both sides this. So what do you write here? Integrate with respect to x both side. So, on the left hand side I will get C1 x, now I will add C1 x left hand side, and on the right hand side I will get minus Gx y2 x divided by Wx dx. This is the integration. So, plus C I can take as a integration constant of integration, and also I will get my C2x from here integration, it will be Gx y1x Wx dx plus constant of integration d. Now, in this case I need the solution, only one solution is needed. So, I will take this as 0 and this as 0. So, from here I will get my C1x is equal to minus Gx y2x, because Gx is known to me, y2x is known to me, Wx is known to me. So, that become my C1x, and from here I will get C2x, that will be Gx y1x over Wx dx. So, this is I can find out once I know the value of Gx, y1x, y2x, Wx, and then once I get this value. So, from here after finding the value of C1 and C2x I can find my solution. So, that solution I am looking for was the particular solution. So, in this case I will get, so this is my C1x. So, I can find my, I can write my here Gx y2x Wx dx. So, this is my C1x, and now I am writing here in the term of x. So, I should just take, so I can write this as t and y1x dt plus I can write here my gt y1t wt into y2x dt. So, from here I can write, so that is my particular solution. So, this particular solution further you can make it, and you can write this as integration. So, I can write from here that gt y1t from here wt y2x, this one, minus gt y2t y1x dt. So, that is my particular solution. So, now whatever the function f(x) we are taking on the right hand side, that function is a continuous, so that is integrable in the given interval, bounded interval. So, from here I can find this integration and then we get the particular solution. So, let us do one example. So, let us take one example. So, I want to solve this one. So, let us take one example on based on this one, y double dash plus 16y is equal to 8 secant 2x. So, let us take this example. Now, in this case the left hand side is the linear equation with constant coefficient. So, constant a naught is my 1 and a naught is 1, a1 is 16, but the right hand side function f(x) in this case is 8 secant 2x. Until now we are we have not done any methods in which if I have the function f x on the right hand side and that is a secant function, I know the method to find out this the particular solution, because till now we have done the solution particular solutions that whenever the function on the right hand side is an exponential function or sin x or cos x or some polynomial. So, this if I want to solve and want to find the particular solution, then I have to apply the method of variation of parameter. But to start with the method of variation of parameter, I should know the two solutions for the corresponding homogeneous differential equation. So, in this case I know that the homogeneous part will be 16 y dash double dash plus 16 y equal to 0. So, from here I know that the characteristic equation will be lambda square plus 16 equal to 0, and from here I can find out that the lambda square will be minus 16 and that gives me lambda is equal to plus minus 4i. So, from here I know that my y1 x will be cos 4x and my y2 x is sin 4x, because these are the solutions we are using to find out the complementary solutions. So, this yx is known to me now, because that was the initial condition to start with. That if I want to start with the method of variation of parameter, we should know that the two solutions y1x and y2x, and they should be linearly independent. So, they are the linearly independent. Now, once I this one, so from here I know that let my particular solution ypx will be c1x y1x plus c2x y2x. So, from here c1x cos 4x plus c2x sin 4x. Now, I know that formula to find out c1x. So, let us find the c1x. So, c1x, I know that c1x can be written as, so whatever the c1x, this is my c1x minus gx y2x over wx. So, minus gx is the function on the right hand side. So, this function on the right hand side is 8 secant 2x. So, it will be 8 secant 2x and y2x is sin 4x. So, this will be sin 4x divided by the Wronskian x dx. Now, the Wronskian I know that this can be found with the help of, so this is the two function I have, sin 4x cos 4x and taking the derivative of this one. So, it will be 4 cos 4x and this will be minus 4 sin 4x. So, from here I can find out this one. So, this will become minus 4 sin square 4x minus 4 cos square 4x, and from here I can take minus 4 common and this will become sin square 4x plus cos square 4x, and this is minus 4. So, it is never 0 because they are already linearly independent. So, this is my Wronskian. So, once I know the value of the Wronskian, my C1 becomes minus 8 I can take outside, minus 4 also I can take outside. From here inside I will get secant 2x sin 4x dx. Now, I know that the half angle formula for the trigonometric function. So, this sin 4x can be written from here, this will cancel out, and so it will be 2 2. So, from here I can write sin 4x can be written as 2 sin 2x cos 2x into secant. Secant can be written as cos 2x and that is a function dx. So, this will cancel out and from here I will get 4 sin 2x dx and this will be 4. So, sin the derivative will be minus cos integration will be minus cos 2x by 2 plus constant of integration. So, constant of integration because in this case we are looking for only one solution. So, this c I will take 0. So, from here my c1x will be minus 2 cos 2x. So, this will be my c1. Now, the same way I can find out c2x. So, my c2x will be again integration. My gx is 8 secant 2x, 8 secant 2x into y1x. So, y1x is cos 4x divided by minus 4 dx. So, that is my c2x. So, in this case this will be minus 2 and it will be secant 2x and the cos 4x can be written as 2 cos square 2x minus 1 by dx. So, this can be written as this one. So, from here divided by, so minus for this one. So, now this become minus 2 secant 2x into cos square 2x minus, so this one is 2 I am writing here minus secant 2x dx. So, from here it becomes minus 4. So, this will you will has only square will cancel out. So, you will get only cos 2x because 1 over secant is 1 over cos 2x. So, cos 2x will cancel out, you will get only cos x, cos 2x here dx minus. So, this minus 2 will go inside and becomes 2 and integration of secant 2x dx. So, from here my solution become now, so cos 2x integration is sin 2x by 2 plus 2 and then log secant 2x plus tan 2x divided by 2. So, this will you will get is minus 2 sin 2x plus this will cancel out and this will be ln secant 2x plus tan 2x. So, once I know the value of C1 and C2, then I can write my general solution. So, general solution will be in this case C1 cos 4x plus C2 sin 4x plus ypx, where my ypx will be C1 is minus 2 cos 2x. So, minus 2 cos 2x into cos 4x plus minus 2 sin 2x plus ln secant 2x plus tan into sin 4x. So, that is my particular solution. So, this is the solution of a second order linear differential equation whose right hand side is a function that is a secant, which is not of the form the case 1, case 2 and case 3 we have solved. So, this is the way we can find out the solution for any general function f x. So, thanks for the watching. Thank you.